So I apologise, we put this man under a bit more pressure than he anticipated, and less breaks, but we've got that management. So, Seamus.
That's everything. Hopefully, boys, the main thing today is it raises your awareness. It's a problem we're having. It's a problem we're having in Scotland, obviously. A lot of water falling, and our drainage system is under a lot of pressure. I originally came from Ballycastle, a wee farm not that far from the Giant's Causeway, Carrigrave Road Bridge, that direction. As Don said, I got an interest in soil science simply because I spent a lot of time whenever I was young, whenever I was 8 or 9, helped my dad put in drains. I was working with the old clay tiles at the time, and subsequently went on to the gravel system. Did my degree at Newcastle, didn't quite get back home, stopped off at Caprice. Whenever he says I was doing a lot of drainage work, I was digging a lot of holes for those first 4 years, doing a lot of investigation. I keep saying to every group, your birthday will come up at some point, or Christmas, or Father's Day, ask your wife to buy you a spade. It's the best bit of machine that you invest in this year. And then use it. You don't need any instructions. It's a great machine. But if you take it out, we're encouraging the farmers to go out now. We've had 2 really bad summers. Last year we had double the amount of rainfall between April and September. And it's caused a lot of problems with compaction. I went on a farm about 9 months ago, and that's really all kicked off again, this interest. It happened to be a farm I had been last on 30 odd years ago over near the Caprice. And I was a bit hesitant with trepidation, would the scheme still be working? We dug down, it was a gravel, it was a silty clay type subsoil, and we'd put in a gravel system. We dug down, and the gravel was as clean as the air went in, and the pipes were working. What they needed to do was go in and rejuvenate the system and get it going again, because it was beginning to struggle, like a lot of farms this year, with the compaction problem from the top. The compaction is one issue we've all to face. But before you do that, just think, maybe it's a deeper rooted problem. Just going in and working an aerator and a spiker or a flat lifter, that's maybe what's needed. Because we're certainly seeing a lot of fields that have never, they've got water lying in them ponded, that had never had that for the last 10 or 15 years. But we're also seeing areas where the problem is actually deeper. It's down below the ground, it's down at the drain level. So we're thinking a wee bit about the problems we see with poor drainage. You drive along, it used to be you saw rushes and buttercups in your neighbour's field and said, well, he's not much of a farmer. Unfortunately, we're seeing more and more of those in our own fields. And it's simply because the water table is getting higher, more damage, more compaction, and we're seeing the sward open up. The sward's not lasting as long, having to reseed a wee bit more often, and we're getting these weed grasses. That's inefficiency. We're getting lower yields of grass or crop. We can't get in and do the work right. You know the problems. Even getting access to the field is now proved to be a problem. We have a lot of big dairies now, and they seem to have increased in the last 2 years. We've got boys now going up to 300-400 cows, and you can put in as many cow tracks as you want. But once they step off that cow track, if you go grazing, that's where the damage has been done. So we're saying to them, maybe we need to start looking at how we actually get these cattle grazed if these summers are going to continue. And I was very impressed with the gravel mould. I think that was a good tip as well. It wastes fertiliser. Waterlogged soils, your nitrogen phosphate are not as available. So think about that. The benefits though are easy to see as well. We get improved root growth. Why do we get that? Roots will not grow if you don't. They need nutrients, they need water, and most importantly, they need air. If they don't have the air, they'll not grow and develop. And if the air pores are full of water, there's your problem. So we're trying at the whole time to create more air in the soil so that the roots better develop, and that's going to help our yield of crops and grass. It's also an increasing problem. I would imagine it's something similar over here. We're seeing more and more incidents of fluke in the southwest. We have sheep farmers that have dosed their sheep 5 times this year just because of the level of fluke. Remember the important bit of the fluke cycle is that wee mud snail. That wee mud snail loves ponded water. So we're now getting to the stage we're thinking we need to be thinking maybe more strategically and start draining some of these ponds and make sure the water isn't lying. And that might help break the life cycle of the fluke. If you get squelchy soil, the correct name would be if the soil reaches field capacity, I call it squelchy. you leave that soil more prone to damage from compaction. It'll lose its structure much more quicker. And that's why these machines are coming and have a good role to play, the aerator, the slitter, or the lifters. But the important thing would be to try and reduce that by trying to keep that water table, bring it back down again. That's particularly true here in Northern Ireland, where you boys have got total NVZ. We don't have that fully in Scotland yet, we've only got it in 2 or 3 places. But I know whenever the spring comes and that open period starts, you're wanting to get out there and spread slurry. So you need to make sure that your soils are able to cope with that. Remember also that there'll be wider benefits. Carbon footprint. Every government, be it Scotland, Northern Ireland, are charged with reducing their carbon footprint. They'll do that in different ways. Nitrous oxide is more common in a waterlogged soil, or a waterlogged soil gives off more nitrous oxide. It's one of the bad gases, it's one of the bad greenhouse gases. So if you have a well-drained soil, less nitrous oxide, you're doing your bit for the carbon footprint. You'll do it another way as well, simply by being able to go in and produce more efficient crops of grass or grain or whatever, because that's basically the secret to reducing carbon footprint far more efficiently. So if you're doing that and able to do that with better drained soil, you'll be helping your government achieve its target for reduction in carbon footprint. How do you know when a soil has poor drainage? Pretty obvious. That's the problem. I've been there in that type of situation. It's easier to get into that than it is to get out of it. So it's better in the long run not to put yourself in that situation, and we do that by thinking a wee bit about drainage. That's one of the outward signs. Another outward sign would be getting stuck in the quad pipe where you're willy, maybe water across the field coming off. It's just telling you water's lying on the soft surface and it's ponding, it's causing problems. Dig down a wee bit with your newfangled machine, that spade that you bought or been given as a gift, and see what's happening. And quite often, soil type, you start off with your topsoil there, and then it comes down into your subsoil, and the subsoil with different layers below that. That critical is at 8-10 inches, and that's what we're trying to keep freely drained. If you dig down, quite often, dig down 20-24 inches, you'll sometimes see the water coming out at the base of the topsoil. That's because it's hit a less permeable material, and it has to bank back up again, and that's where we get this idea of a perched water table. You might also see it in the roots will be shallow, maybe brown. You'll see colours in the soil, this mottling, and that's just a sign of intermittent wetting and drying, and that's the iron in the soil settling out again. It's in solution whenever the soil in the summertime gets drained and the air comes back in, you'll see it settling back out again. Sometimes you see it even in roots. Like in here, you'll see there, that's a glaze soil. That guy's got a lot more problems because that soil will be periodically wet, probably for 7, 8, 9 months of the year. And you can see the impact it's having on the soil structure. There's no cracks, natural cracks or fissures. It's a grey colour. Those are the outward signs. The types of problems that you'll come across, this one here, water on the surface. 30 years ago I wasn't seeing that. It is a new problem, it's understandable. The weight of machinery has increased, the intensity of farming has increased, the number of livestock going across the field kind of increased. We're seeing fields that have been ponded. I saw one about 5 months ago, and the fellow said, "You come down, I've got an area, big pond, it's appeared overnight." I said, "What happened?" And we went out to look at it, it sloped down, and he put slurry on in the umbilical, and whether it was a result of that running down and sealing, or whether it was just compaction further out, and then whenever it got heavy rain again, he says it rained really heavy the next 3 or 4 days after I put it on, and it just got washed straight down into this pond area. I said to him, "Are there any natural drains to get down to clear this pond?" Because quite often solution there is just to find a drain and gravel back up again, create some, get it away. He says there's no natural cracks or fissures, there's no natural drains in that, it's free draining before. I says, "What are you hoping to do?" He says, "Well, I'll run the subsoil through it." But if you do that, that'll be a big disaster, because all you'll do is shift the water from the top right down into the top 18 inches below ground. What's it going to do? It's going to sit there for ages. So the solution was to go in and actually pump that off. It was 230,000 gallons of water. You the umbilical pump back in and pumped it back out again. Waited 2 or 3 weeks, and then he went back in with a flat lifter to try and solve the problem of compaction. So this is something we haven't seen, but we're seeing it certainly this year, and it's because of the extra rainfall we have over the summer. Springs are a more unique problem. I think about solving them simply by, you must tap the spring, at least find out where that spring line is. You'll spend more time, but it's time well spent, finding out where that source of the spring is. I saw one boy one time, and the spring was down, he dug down 5 or 6 feet. He ended up putting a 6-inch pipe on its end to tap it and bring the water up, and then lead it away and get it away. I spoke to a contractor recently, and he said, I'm going in, this will be my 3rd year, going in to try and sort this field. The problem just seems to move. I said, you've never actually gone and tapped the spring. So you must, it's a difficult to sort, but a wee bit of investigation is going to pay dividends there. The 2 most common ones that I was coming up against 30 years ago, and they're still there, is the groundwater and surface water over these impermeable type subsoils. Start off with the groundwater. It'll not be dissimilar to areas around Loch Ness, anywhere you've got rivers, alluvial soil, even the shore. And the problem is always this water table rising up and down. And all you can do is try and control it by putting drains in and leading them out. Your drain depth will be dictated by the outfall, whether it's into a river, into the sea, or wherever. But the deeper you can go, the better with a groundwater problem. The deeper you can go with a groundwater problem. Traditionally in Scotland, we have it now, you speak to farmers and they'll say, you need to be down deep. And why is that? Because the old clay tillers were not down deep. They were down 3 feet, in some cases 3.5 feet. In some cases, a lot of them were done by Irish navvies that came across about 150 years ago. And I said, those boys must have been working hard, but they were doing the things wrong. That's fine if it's groundwater, but not if it's a surface water problem. So think of the problems. But groundwater, deeper drains, we don't necessarily need backfill around them if that's the only problem, because these soils tend to be more sandy, alluvial type, free draining type of topsoil. You may put a bit of gravel around, pea-sized gravel as a filter, and leave it at that. It is possible though, you may end up with some surface water problems as well. You may still have to go in, but that's where you've got a combination. If it's just a groundwater problem, deep drains, and you decide, the closer you bring them, like all drainage, you'll lower the table, you'll have a bigger impact, but you'll have to decide again in cost. So that's the groundwater, reasonably straightforward to solve. The surface water problems is our most common problem, be it in Scotland, be it in Northern Ireland. And you think about what's happening, we've got this free draining or better draining topsoil, the water can get through, then it hits something that's not as well drained. The water will still get through it, but it'll take it some time. Now if you're in a flat area, so this is my less permeable subsoil, and there's the topsoil. If you're in a flat area, all that happens, the water comes down, hits this, waits, banks up, and eventually get a perched water table. The water table rises back up again. And at the same time, probably the cow's feet will come down this way, and where they meet, we get big problems with compaction. So we're trying to keep that clear. It's fine if you're on a slope, it'll help, it'll keep itself clear to a certain extent. It'll run along. If you dug down there, you'd see that all that water come along there, and eventually it'll run out and begin to pond back out again when it runs out of slope. That's a surface water problem. We're dealing with impermeable or low permeable subsoil. The solution, it's not the pipe that's important, it's this gravel connection back to where the damage is. So you're trying to get the gravel connection back up to the base of the topsoil. And in Scotland, that's all we go to. I know in Northern Ireland it's common practice to go right to the surface. Think of the extra cost of gravel, but you must get it to that level. That's where we're going to get the interface, take that water collected, take it quickly to the drain. Here, it's a surface water problem, so why do we need to go down deep with these drains? If the drain's down the way down here, it's extra money, extra cost, and extra time, even for the water to get down. And you have a harder job getting the run of the drain if you put it way down here. I'm talking about going down 3 feet. So I wouldn't be going any more. 26, 28 inch cover is plenty. The drain will stand up to that because you've given it a gravel envelope. And we're using this free draining, clean gravel, whether it's stone, whether it's 1/4 inch, whether it's pea-sized gravel. It doesn't really matter. It's the connection that's important. How wide should they be? In an ideal world, the closer you go, the bigger control you have in the water table. So even this perched water table, the closer I go, I'll have a bigger control. That's out at 10 metres, that's at 5 metres, and that's at 2 metres. The problem is, your pocket. You don't maybe have deep pockets. It's all right. Playing fields, they'll go down to 1 metre. And go with sand slips over the top of that as well. Same problem, but you can't do that, you can't afford to do that, or can we? There was a problem we were faced with 30 years ago, and we came up with a solution which was to think about secondary treatment. So with the primary treatment, we still are leader draining the gravel laterals, but then we're going to superimpose on top, we're going to put a whole lot of secondary treatment, in effect, closely spaced drains. Whether those were molds, mold plough, or subsoil, it's the same idea. With subsoil, you just get a lot more cracks all want to run. But the important thing is, you run that at an angle across into your gravel connection. So the gravel's doing two jobs. It's providing the connection initially in its own right, but it's also now offering a very quick connection for the secondary treatment. Did it work in practice? We did a trial in 1981 on a farm down here on the route down to Carlisle. A dairy farm, pretty heavy silty clay. It could take a mould because it had more than 35% clay. It didn't have sand pockets. The biggest challenge was trying to convince farmers at that time. We were used, drainage is all about traditional. And tradition on that site was 7 metre spacing. With 7 metre spacing running up and down the slope. And if you think about it, if you have a drain there, and a drain over there, the bit in between, and the slope growing, that water is going to run all the way down and keep running. Whereas if you put the drain across the slope, you connect it further up the field before it's got the chance to do as much damage. So that was a challenge, so we decided we'd go in, and we didn't go for 7 metre, but we went for 10 metre spacing across the slope, and we compared that to 20 metre spacing across the slope. And this side we just went to the secondary treatment, which was, in this case, was mold plough. It could have been a subsoiler, in this case it was mold plough. Did it work in practice? We looked at drain flow, we took measurements every week, and we wanted to see how quick could that topsoil get dewatered. When did the drain stop running? And you can see what was happening with the secondary treatment. The drain started running very quick, and look how fast and how much water was running, and then gradually slowed down. And by about 2 days, just about, it stopped running. The other 10 metre spacing, the closer spacing, it was fine. It was still doing a good job, but it wasn't as effective. Because it's still in a drain every 10 metres, this is a drain every metre. So that's the difference in the benefit of secondary treatment, if you're able to do it. The biggest problem in Scotland, where I am, part of Scotland, is a lot of our soils don't suit the mould, and we're relying more and more on the subsoil. And for that, you're heavily dependent on the weather, particularly in the late spring, early autumn. And the last 2-3 years, we haven't had the weather for subsoil. The subsoil hasn't been drying out. And if you go in too deep, whenever it's too wet, it'll just form kind of a mold. So just think about the timing of the treatment. It definitely works. Types of problems, I said at the beginning, we did a survey and we were getting as high as 22% of the new schemes failing. That was 2 years after these expensive schemes were getting in 7% grant. And why was that? It was a combination of 3 factors coming together at one time. Plastic pipes had been introduced. Previous to that, it was clay tiles. The benefit of the clay tile was you could see it if you had put it in wrong. It was easy to see from the surface. The plastic, there's a tendency at the beginning, people didn't know how to handle plastic over our side of the pond, and they were going along the contractors and they would just kick it in. And it was going in up and down and sideways, and then they would backfill. And a lot of farms, it wasn't traditional to use gravel backfill. Now, there's some soils you can get away without using gravel backfill. But even where they were draining, you should probably be using gravel backfill, that might help. But they were going in, put these pipes in, and then just backfill over the top. The right way to, or the best practice way to lay a plastic pipe gravel system, I would always start off, dig your trench as flat as you can get it, or a break flow, and then stick in the first 2 inches, first 1 inch or 2 inches of gravel. It doesn't need to be any more than that, and that gives you a nice clean bed for the pipe to sit on. That straight away means that your slots, there's as many slots in the bottom of the pipe as there is in the top. Those slots are sitting nice and clean from the day the pipes fit in, able to receive the water. Stretch it a wee bit, don't overstretch it to weaken it, put in some bats of stones to keep it in place, and then carefully with your gravel wagon, or if it's a link box with gravel, you're shoveling in, put your first shovel for the stone in carefully so the pipe doesn't bounce up. And because you've only got 60 mil of pipe to work with. Once you've done that and you've covered it with 3 or 4 inches, you can go away and leave it, or you can let the young fella loosen the gravel wagon and bring it up to whatever level. You're not going to do any more damage. You've done the important bit, got it right, got it off, and that in itself is going to extend the life of that scheme. The other thing we had was the type of machine we were working with. We were back 30 odd years, 35, 40 years now, and they were using the back actor. Absolutely nothing wrong. Good machine, be a back actor, digger, digging a trench. There's no problem with that. But they were using it the wrong way, simply because we had soils they should have been using gravel backfill with this surface water problem. And they said, oh, we've never done that before. But at that time, they were always using the back actor, and they were maybe taking the topsoil out, setting it to one side, and then maybe put that topsoil or sod back in again on top of the pipe. And that in itself was free of drain. It was almost like acting a bit of a connection. And then even the sods you were putting back in themselves, you had these natural cracks and fissures. So although it wasn't gravel backfill, it was almost serving the same purpose. We began to change from the back actor to a trencher machine. And the trencher machine is a chain on at the end here, and it sends the soil out 2 sides, and all they did was coming up. They were coming back in again, and they weren't using gravel at this time, and they're just bulldozing that in and filling the trench. So we had a nice pipe, and we had it sealed with that material, because there was no mixture at top. You couldn't separate the topsoil. That machine just was grubbing up everything, so you ended up getting topsoil and subsoil mixed. Something and sealed over the top of the pipe. We had no connection. So that was a damage mistake. We even tried it with the Trenchless Machine, and that's the business end of it. It's just like a giant mold plough, and it only has 100 mil, 4 inches spacing. And so you think, how easy for it to seal again without gravel backfill. We started saying to contractors, you must start using gravel, and they started putting the gravel hopper on the back and going through. The benefit of that machine is output. You can horrendous amount of acres in a day with that machine. You're only using 4-inch wide gravel, so it's more efficient, cheaper in that sense. We did run into 1 or 2 problems with bigger stones. I tried using a 2-inch stone, 1.25 2 inch, and it started bridging. And they began to say the only way you can actually do that is using 1/4 inch or pea-size gravel. So again, for that type of machine, 1/4 inch gravel or pea-size. Tradition, we now, unfortunately, a lot of our farmers now think that's the only stone you should be using for drainage. Nonsense. You can get away with your 2-inch as long as it's clean material. You only need to de-gravel if it's specific, if it's running sand or you're trying to use it as a filter. Any other time, the kosher gravel, as long as it's clean. We're now seeing a group of farmers, big dairy boys with thousands of cows over near Castle Douglas, and they're saying the price of gravel, 2D or £15 a tonne with us. If I use my own rock, I can get it £3 a tonne. And they've now started digging out and just backfilling with the rock. And I can see where they come from, and it's fine. They've even said, to avoid the issue with the plastic pipe and maybe big chunks of rock dropping on it, they've opted for a twin wall, thick plastic pipe, double skinned, 100 mil, costs £1.40 a metre compared to maybe 50 pence a metre for the 60 mil plastic. And I'm saying, boys, you don't need to do that. You'd be cheaper to go and actually spend some cheap gravel and then still go with your rock. But you'd be better to fit your rock and spread it over a grill and make sure it's clean. The other thing it'd be better to do is not if the trench is wide, and that's one message you boys should take home. We would have been quite happy at home with the work an 18-inch bucket, 20-inch bucket, tapered down to 12-inch, and made a good size of trench, and the gravel was not too expensive, and that's the system to work with. In Scotland, we quickly contractors start thinking about using a 12-inch straight bucket. Some even get down to a 10-inch straight bucket. In Ireland, you can get away with, because you'll use less gravel. You still get plenty of gravel for that connection, more than enough. So I can just think with the Trenchless Machine, it's only a 4 inch. That's still a good enough connection. 12 inch more than enough, or 10 inch more than enough. It doesn't need to be, and you use less gravel, you can do more acres that way over the ground a bit quicker as well. So that's the Trenchless Machine work with the gravel going in at the back. How are we doing for time, Don? 5 minutes, alright. I'm still going to use this because it's a good take-home message again. I'm actually going to leave that because I'll give you the answer anyway. Just think of this. This is a sloping bit of ground coming down into a flat area. You know, it's a shallow flat bit. It could be 5 acres, it could be 50 acres. Your eyes are always drawn to these flat bits. Unfortunately, sometimes it's a more difficult bit to drain because it could build up peat because there's always been plenty of water. I would normally have asked you where would you normally start to drain, and quite often farmers would say, oh, we'll go straight in here, we'll go with herringbone. And then there'll be another group that say, oh no, there might be problems with ochre in there, it would be better to go, if this was a burn, we'll go in and we'll just put a couple of straight laterals through, and then we can get and rod them, because that's the important thing for dealing with ochre. And I was saying, but hang on a minute, that's not covering, sorting the problem. All that's doing is coping with the water that's falling from above. What about all the water that's running in at the base of my topsoil and feeding this area, because it's going in here something. So the sensible way, and if money is tight, that's where you start. That's the first drain you put in. Is this catchment drain, a curtain drain, to isolate the site. Do that in any of your drainage. You'll see it if you're building houses, so it's going out the motorways. Talk about storm drains, curtain drains. That's the most valuable and cost-effective drain you can put in. And after that, then you go in and drain this to your heart's content, of whatever space and whatever. Now, if you don't sort the problem here, stop it getting onto the site, it's not as efficient or as effective. Change that next thing, Dom. What's the problem? You can't tell just looking. That could be a burst drain, it could be compaction. That could be compaction, it could be a burst drain, it could even be springs popping up. You're not going to be able to tell unless you go out and start investigating. And don't be frightened to dig a few holes across a field and get a wee digger and dig a few holes across a field and try and work out what's going on. You'll have different soil type, you'll know your fields, but there may be different soil type across a field. And you may have to, that may influence how you set about trying to drain that, or the types of problems. You may have running sand in one corner, you may have deep peat in another bit. You may have bits where silty clay is causing you ochre. You decide. You may have bits that's got better slope, you go a wee bit wider. I would always start at the ditch. Sounds a bit very sensible. If you've got problems, go back and see if your ditch work. Does that need to be cleaned out? We've had a lot of farmers who've gone this year, this spring, and started cleaning out the ditches. And they've said, not only has it helped, it's got, with a wee bit of pressure, with a wee bit of rodding or jetting, you've been able to get their drains running again. And you haven't had to go in and do a full system. It's just a wee bit of maintenance. That's particularly the case if there's iron ochre in it. The jet may get it going. When you're using gravel, the one thing I'd always say, if you're using gravel, you bring the gravel right out to the mouth of the drain, but you stop before that. Good practice to put a 2 metre straight pipe on there to bring it out into your ditch. It's even better practice to bring the gravel to there. Because if anything happens to that drain, the gravel will still act as a stone drain. So make sure you connect that right to the mouth of the ditch or into your leader. You need to investigate and decide what the real problem is. It is expensive. I always say, if you know the system, leave it well alone. It wasn't drained for a reason. Clever men, and you might have tried it. I'm over in Scotland, I always say, if it's peat, leave it, unless you're Irish. And the reason for that is it's difficult soil to drain. It's got a very low soil conductivity. You would need to have drains every metre. So it might not be the first one you should be trying to sort. It might be the ones further up the slope. You'll be able to drain easier. You need to think, are you able to drain? We've already covered the design. You're going to be going across the slope. How close should the laterals be? All of point out, the spacing is going to depend on how deep the pockets are, how much slope there is. You can get by with wider spacing if you've got a nice or stronger slope. So it might be 10 metres at the top, might be 15 metres further down. You might even be out as wide as 20 metres if you think of the secondary treatment. And you're thinking of intended land use as well. A dairy boy might, or a cropping boy might want to spend a wee bit more, be able to afford to spend a wee bit more than beef and sheep. So you have to sit down and decide the spacing is going to influence the cost. 7-metre system, 600 metres of drainage every acre. 20-metre spacing, 200 metres of drainage every acre. So you can do 3 times the amount for the same cost. Think a wee bit how long your pipes are. Just because you put a pipe in, a 60 mil on that fall can only ever take 100 metres before it fills up with water. So don't design it like that. You should really be grading up to another pipe. So you'd start at your ditch, do the first 70 metres with 80 mil, and then grade back up to 60 and do the last 100 metres. It's not too big a problem, because if you're using gravel backfill, it'll still run, it'll act as a sump, and it'll wait to get into the drain and away. It may even run through the gravel. How deep for the pipes, I've said, it depends on the problem. If it's a surface rock problem, don't go over deep. I'm saying 26, 28 inch cover is plenty. If it's gravelled, a bit deeper for the leader, and deeper again for peat, because peat will dry out and shrink. I've seen cases where, I've seen it at home, we put the drains in, my father said the peat is shrunk, and sure enough it had, because it dried out. He thought the drains had risen, but the peat had actually shrunk. So allow for that, and it'll come close to the surface. It's going to be governed by also, do you have any old systems? In Scotland, we have to think about the old system. We have these drains going up and down the slope every 7 metres, and some of them are down 3 foot, some are down 3.5 foot. They're down 3.5 feet, I leave them well alone. If they're sitting around the 3 foot and still working, I'll go with every third lateral going across and go deeper. I'll not do the others as deep as that. But think of how you connect the old system as well. Size your leader accordingly. A 6-inch plastic, a 6-inch plastic R drain, one will take 5 hectares, one will take 8 hectares. Quite a difference. This has got turbulent, it's the corrugations on the inside, and you get turbulence. You get the smooth R drain, that could have been a 6-inch plastic, 6-inch concrete, smooth, no turbulence, you carry a bit more water. I think gravel backfill, its main purpose is to maintain this easy route to the drain, get that topsoil deep water quickly. It can also connect into the old system, it can act as a stone drain if anything goes wrong. It does allow secondary treatment, but the gravel itself is expensive. It doesn't mean you can always go wider, but you can if you can use secondary treatment. Just think about the cost, make your money go further, don't have drains too deep, only gravel to the base of the topsoil, or a couple of inches above it. Doesn't need to go to the surface, you can always go back, and there's bubble holes sort there. Definitely think about an higher trench, but you can go down to a 10-inch bucket grade, and think of sensible spacing. You see the cost really go out. Only do it whenever it's dry. That sounds easy, it sounds a bit common sense. I think boys in Northern Ireland tend to do the drainage in summertime. In Scotland, we have a tradition again, we drain in the winter time. And you will have a 50%, you're more likely to have a failure if you drain in the winter. Don't backfill pipes with wet slurried soil. Make sure your outlets, if you've got peat, just think the issues there. Ochre, individual outfalls, so you can draw the drain. If you're not prepared to do that, put in your manhole and lead a couple of drains into it so you can still get in and draw to jet them. Roots, just think about roots. Where you pass trees or hedges, they should be sealed. Brother was telling me yesterday, we put in a 6-inch, we picked all the shucks about 40 years ago. And he was saying, he was giving off, he said, he dug in and he says, we should have gone for perforated pipes with 6-inch solid concrete, sulfate resistant. And he said, we should put gravel around them. We should put the gravel around, and that would help maybe other field drainage. But he was telling me also that there was roots in these 6-inch pipes, and you have to maybe start sorting them as well. So where you've got a hedge or a tree or that, come out a bit. Don't put them right, put your leader drain right in tight. Come out the field a wee bit. We saw some of the problems with boys putting kale in or rake after they've done the drainage up in the hill situation. And if you happen to get a dry summer, the roots went straight for the water. Where was the water? It was in the drains. And that's where they went. And I saw 30, 40 acres of one farm destroyed simply because when it got to the stage we were actually recommending where you've got hail in, and if you were thinking it's going to be a fairly dry summer, you go in and spray off a strip across the top of it where you drain. So think about roots, some of these other problems. Think also of your wider responsibilities, be that ESA, triple SIs, or the bits you're not allowed to drain. You might have been allowed to drain 30, 40 years ago. Think also about your cross-compliance issues. Speak to Don and his team about that, they'll keep you right. Because over with us, you can't go up and drain Virgin Hill. You can use cheap drains, but you can't drain Virgin Hill with rough grazing. You shouldn't be piping shocks without consent. And when it comes to shock maintenance, think over with us, we're now told our environmental people would say you can only, it used to be you would go down one side, across and back up the other side with the jib of the digger. You can only start, across, pull up. That leaves one side with the same vegetation for the wee beasties and bugs to still run. Take home points, don't rush in, pick the right field, decide what's going to make you the money. You must work out what the real problem is. Do you need a totally new scheme, just a partial scheme? Design it right, think of the space, and think of the gravel need, the depth, other problems, work out the cost benefit. I say use a drainage contractor, hopefully experienced, not somebody that is just able to jump on a digger. Seek independent advice from Darren or wherever, and be aware of your environmental responsibilities. I'll come to the end again.
I'm sorry, we have another group jumping at the bit at the back there in the marquee, so we'll have an opportunity to take questions, but thank you again, Seamus.
You get a lot of chance with the next groups as you go round, just give it think a wee reflect and think a wee bit and ask some of the questions to these boys.
We'll run back in and ask him, okay?